Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In this lesson, we're going to talk about struct delegate constructors, which is just a neat feature that you have, and you might have seen this again in other programming languages, but I want to go ahead and show you from the D perspective. So let's go ahead and take a look at what a delegate constructor is. So what I'm going to go ahead and do is take you to the documentation, as always, on our favorite webpage, dlang.org. Let's go ahead to the language reference here, down to structs and unions, and again look at struct constructors here. So from the constructors tagline here, category 13 at this recording here, what we'll see here is that if we scroll down just a little bit, there's something known as a delegate constructor. And this is sort of as it sounds here, but this is the ability for a constructor to call another constructor during creation. So what this allows us to do is ensure that we have some series of code that can be called just during the construction phase. So this is known as a delegating constructor. So let's go ahead and talk about this and look at some of the different trade-offs we have with this with our example here. So again, we've been working with this little vec3 example here, and let's go ahead and see what a delegate constructor is here. So what I might want to do here for this example is let's just go ahead and create two constructors here. In fact, let me just simplify this down to one constructor here, where I'm going to have the float for the value and the float for the W value here. Now, for some of you who have done game programming, you might be aware of, for 3D game programming especially, even though you have a vec3, sometimes we sneak in this W here, which might be meaningful. But for the purpose of this example, let's just focus on the delegate constructor. So I have one way to construct a vector here, where I might have sort of two operations that I want to set up here. The X, the Y, and the Z here, and then setting up W here. Okay, so two different sort of groups of things that might need to be set up. And what I'm going to go ahead and do here is just create another constructor here called this, and I'll just set the float for W here, and say this W equals W here. Okay, so I'm actually going to call this constructor here for the W value here. Okay, and then let's go ahead and actually use this in our code, and we just have one constructor here. So I'll just go ahead and use this for our construction, where we use the values of 1.0 and 0.0 here. Okay, and let's go ahead and just get all this code on our screen here, so we can see our two constructors here. So here's the constructor that's going to be called, and then it's going to follow this code path here to then call this constructor, which initializes the W component here. Okay, so let's go ahead and run this example here, and we can see that this properly initializes all of our values to 1, followed by a 0 here. And then we could go ahead and contrast this with, well, what if I just call our other constructor here, vec3, v1 equals our vec3, and I'm just going to call this constructor with one argument, because again, depending on the number of arguments that we provide or the types in our argument list, that's what will be called here. So I'm just going to provide one floating point value, which is just this one here. So go ahead and do that, and then let's print out this vector here. And we'll go ahead and see that this one will use the default values and just set our W value to 1.0. Now, is this a good API? Maybe, maybe not. So don't get hung up on those details, but just again, observe that we didn't call, we just called this constructor and that was it. Now, here's the thing to think about and why are delegate constructors useful or interesting? Well, you might also argue that we could just provide a free function like void and call it init and just initialize our X, our Y, Z and W value here in some function here. Okay, and we could do, you know, this dot X equals X, and let's just go ahead and finish this off here. So this actually might be, in this particular API, a useful function to have, and we're going to look at something called a copy constructor later on that might be, you know, even more beneficial for this type of thing. But the idea is I want to have some code that's guaranteed to run before we actually start using or manipulating our vec3 type. If I just use a regular function here, like init, that could be called at any time after construction, well, again, that's not as useful for me here. So that's why we use constructors to guarantee that this code will be run, and that it has a proper interface that this code is just called at construction. Because for instance, again, you might argue, why not just call the init function here? Okay, where we could also pass in 4 arguments and then use this function. Well, clients have access to this init function here, and they could freely call this function if they want. Now we can try to prevent this by marking it as private and so on, but again, it's just a clear interface if we have constructors for code that's just meant to be called at initialization of our objects. So oftentimes you'll see this if we have resources like loading files, maybe setting up locks, or these types of things here in various delegating constructors. Okay, so this is just, again, a nice feature of the D programming language to know about and when to properly use it. Okay. Other languages do support this. Modern C++, C++11 and beyond supports this if you use that language. But again, we have this great feature available in D as well. So that's all there is to this lesson. You can read more about delegate constructors here. We do have a few restrictions as far as how they must be used, meaning that, well, if we're going to call a constructor, we can't have an or, right? We need this constructor to be on all paths. And part of this is, again, with this idea that when we're constructing the object, we want to make sure that it finishes and it initializes. All right, folks. So with that said, if you enjoyed this lesson, be sure to check out all the other lessons here on my webpage. If you've been enjoying this, you can track your progress and sign up there. And otherwise, folks, I hope this was an interesting lesson, just bringing yet another feature of the D programming language to your attention that just makes it a really neat and modern language. As always, folks, I'll look forward to seeing you in that next one.